When we talk about the machine learning projects, reproducibility is a foundational pillar in the machine learning operations. Now, this reproducibility ensures that the machine learning models can be consistently retrained, redeployed, and validated under the same conditions over the period of time. Now, in this video, we'll explore what are the practices that we need to follow in the machine learning project so that we can implement the reproducibility. So, let's get started. So if we talk about the overall pipeline in any machine learning project, so we have the data ingestion. Now, data ingestion is a place where we are going to receive the data set. And we have a data processing step. Now, in the case of this data processing step, we will get the data, we will perform some kind of transformation on top of it. And then we will go ahead and perform this transformation, user transform data to the further steps. That's called as the data pre-processing or the data processing step. Then we have model training and experimentation, where we will train multiple machine learning models and choose the one that's suitable for the given task. Then we have model evaluation step, model deployment, monitoring, and maintenance. So these are all the various steps that we have when we talk about the overall machine learning lifecycle. Now, when I say MLOps, MLOps is about operationalizing this entire machine learning pipeline so that we'll be able to ensure the reliability and reproducibility, and we'll be able to deploy at scale as per the requirement. That's the overall idea about MLOps. Basically, it's the combination of DevOps principle to the machine learning project. Now, when we talk about reproducibility in MLOps, the reason that it's very important because when we talk about MLOps, first and foremost is the reliability. So we'll be able to have a consistent result. Now, if you are able to achieve the consistent result, that's going to increase the stakeholder confidence. And imagine, guys, let's say you have the machine learning team have developed the model, and if that model starts behaving unpredictably, what would happen? Well, it becomes challenging to trust the output that is being generated by those models. And more importantly, when we have a reliable model, it will also help us in identifying the issues, diagnosing the issues. It will help us to retrace the steps during the model failures. And lastly, especially on the fields such as healthcare and banking, where people are involved, it's not only the requirement as a technical requirement, but it's a compliance requirement. In the regulated industries such as healthcare and banking, reproducible processes are critical for auditing and ensuring that the models meet the legal and the ethical standard. Now, what are the challenges that we have to face, and what are the solutions for it? Now, when we think about the data ingestion, so data ingestion is a step where we receive the data from multiple sources. So these data, whenever we are receiving, these data will evolve over the time. Now, as and when we start using this particular data and start training, okay, and then let's say I have received some other data when I go for evaluation. Let's assume that for the illustration purpose, let's say I have 100 rows over here during this data ingestion step. Now, when I reach the data processing, so maybe this became 120 rows in my data set. And then I've used this 120 rows to perform the training. When I'm doing the evaluation, now let's assume that I'll make use of my source data and do the evaluation on my model. Then in such scenario, when I talk about the source model, by the time the let's say the model training completes, the number of rows becomes 200. Now I'm going ahead and performing the evaluation on the 200 rows. This can happen if you are not tracking the data. Here in this case, it's a real world scenario where the data set are getting evolved over the period of time. Now, in case if we have these kind of inconsistent data set pipeline, so one of the common solution over here is data versioning. So one of the common practice that we follow is data versioning. So here, when I say data versioning, so we will track what exactly is the data that we are having at a particular period of time, and we will use that version of data in every process that we are having a data dependency. Now, in order to implement this data versioning, we have various tools like we have DVC, we have like a similar tools as well, like okay, like I can remember DVC right now. Yeah, you can say DVC, and we have pack item. There's one more tool that we have got that would help us to version the data set. And another key thing that we have to take care is the code versioning. So whatever the code changes that has been applied during the, let's say, data preparation, the same code or the same version of the code has to be used in our production environment as well. So code versioning is another best practice that we generally implement in order to ensure that we have a reproducible code. In order to perform this code versioning, we make use of commonly used tool. As for the code, we make use of the Git, which is a commonly used tool for tracking the changes in the code base. Then we have model training and experimentation. Now, here, when it comes to model training, so we will train the model, and at the end, we'll have a model artifacts. Now, in once we have the model artifact, it's very important that we take care of the model versioning. Since I'm talking about versioning, I'll include this over here as well. I'll say model versioning. Okay, so model versioning will help us to keep records of model versions. Okay, that's the best idea over here. And in order to perform this model versioning, we also make use of the tools such as DVC. Generally, we use DVC only, not the Git, because when we talk about model, the model can be of varied size, and we prefer to save it in a separate place other than the code base. Hence, we use the tools such as DVC. Then, another key aspect that we have to remember when we are working in this kind of complex project is the overall environment management. Now, when I'm performing the model training, I'll have various options. Let's say I'll make use of scikit-learn, or I might make use of XGBoost, TensorFlow, PyTorch. And in some cases, I'll be using a specific version of a library. Then in such scenario, one of the key things that we have to take care to ensure the reproducibility is the environment management. I'll mention this separately right here. So here, when it comes to environment management, so here one of the best practice that we follow is we make use of containerization. So we make use of containerization tools such as Docker and Kubernetes so that we can encapsulate the overall environment in which the projects are running. And if I'm performing any coding or writing or creating any notebook, okay, or if I'm creating the project locally, so one of the most common practice that we use is we leverage virtual environment. We leverage virtual environment, so or the Conda environment for managing the dependencies. So this is about the environment management. And the another key aspect that we will generally come across, especially in the complex machine learning project, is the model training itself. Here we this task of training the model, we call it as an experimentation. Now the reason that we call it as experimentation because we have various frameworks, we can try out various configuration for each and every model, and we'll try out the various settings, and at the end we'll choose the one that is suitable for the data set, which is giving us the better outcome. Now, in order to track those experiments, we make use of the tools. So I'll mention as experiment tracking. I'll call it as experiment tracking. Here, in order to track the experiment, we'll make use of tools such as MLflow, weights and biases, or the tensor board, so that we can go ahead and log the experiment data the parameters, metrics, and the artifacts. And it's also recommended to include logging, detailed logging over here in the code, so that we'll be able to trace the parameters and understand what exactly was the setting that we have used. We can trace back and ensure that we'll be able to use the same setting to have a reproducible outcome in the other environment. Okay, this is called as the experiment tracking step. And the another key thing, like it's normally taken care by the data scientist itself, but I just want to highlight, if in case we are trying to make use of any random seed, so or any random functions that we have in which are built in inside the Python, like for example, if I'm using TensorFlow tensors or NumPy or PyTorch, like this is actually the role of a data scientist. So if a data scientist is actually trying to create a matrix over there or generate the list of numbers or the weight matrices for training the model, then it is recommended to use the reproducible seed. We call it as a seed. So I'll say use random seed. It will actually come under the experiment tracking itself for reproducible in generation. Okay. Next, what are the other things that we have to take care to ensure the reproducibility? The other thing that's recommended, I'll mention it on top, that's the automated testing and CI/CD. So here, it's recommended to implement a unit test for individual component. So for each and every component that you see right here, it's always recommended to have the unit test for the individual component. And whenever we are performing any changes or any changes to the overall application, whether it can be changes in the data, changes in the model artifact, or even changes in the code, in such scenario, we have to implement CI and CD so that we can run automatic test and validate the changes. And lastly, even though everyone hates it, we'll have to have a documentation. Now, with various tools that we have in the market, so we can now make use of various generative AI tools to generate the documentation. But documentation is one of the critical aspect in any MLOps project. So, to have a quick summary, when we talk about MLOps, it's about operationalizing the machine learning models at scale. Now, to ensure that we operationalize it, we have to ensure the reproducibility, which is one of the critical tasks. Now, to ensure that the projects are reproducible, so we have to take care of the data with the help of the data versioning tools like DVC, take care of the code with the help of Git, take care of the model with the help of model versioning tool like DVC is the same tool that we use it even for model versioning. And to ensure that we are able to track the experiments during the training, we make use of tools such as MLflow, weights and biases, or TensorBoard for logging the training parameters, the settings, as well as the metrics that we have generated. And while writing, we make use of the reproducible C to ensure the repeatability, to ensure the similar behavior, and it works everywhere. We make use of containerization technologies such as Docker and Kubernetes for orchestration of such container. And while managing locally, we make use of Conda to manage the local environment. And we implement the unit testing for the individual components of the pipeline and implement CI and CD where we integrate the code with the help of the CI tools and implement this automation testing and the continuous deployment on this validated code. And lastly, the documentation. So overall, I can say that this reliability in our MLOps project is not just a technical requirement, but it's one of the core aspect of building a reliable, scalable, and auditable machine learning system. So by implementing these robust versioning, environment management, and the automated test practices, guys, we can ensure that the machine learning models remain consistent and trustworthy throughout their entire life cycle. I hope you had fun learning in this video.
So, folks, if you want to join live from the next session, just check out the link that is provided in the description. Join our community, and I can't wait to help you in your MLOps and generative AI journey. Take care, guys, and I'll see you next time.